From a certain perspective, everything can be considered a signal that is passing through a system. Whether it's electricity going through a circuit or water passing through pipes, if you want, you can attempt to model anything as a system. As this is an electrical engineering textbook, we'll be focusing on circuits and the typical signals we encounter in electronics and electrical engineering. One of the most common signals we deal with are sinusoids, which, while simple to understand their shape, can become quite complicated. They're typically shown mathematically as a complex exponential, though we'll sometimes see and deal with them as a sine or cosine function. As we'll work with complex numbers so much, Dr. Johnson briefly goes over complex numbers in this chapter. Next, we go over discrete time signals. As most signals are digitized nowadays, it is very common for the signals we deal with to be digital and discrete. We'll cover the building blocks of different types of signals we can expect to encounter both in academia and in real life. To simplify things, signals can be reduced into multiple smaller signals, which is known as signal decomposition, and this will also be touched on briefly. Once a foundation of what signals are and how they can be broken down is covered, Dr. Johnson starts going more in-depth with systems. In essence, systems are things that manipulate signals. We can deal with most systems as black boxes that are simply mathematical representations of what will happen to any incoming signal and, without knowing what's going on inside the black box, we'll still know what to expect with the output signal. Once we know how to model these systems and deal with them, we can start to connect them together, feeding into other systems, creating feedback loops, and getting much more complicated and powerful results. The chapter finishes with learning about the different general parts of a system, from sources to amplifiers, things that represent the way real-world systems affect or create signals.